Welcome to Secure Compute and Multipath Communications for Edge and DDIL environments. I'm Rob Grote, EVP of Technology and Strategy at SMX. SMX is a global solution provider for ISR capabilities across the combatant commands. And I'm here with Rob McGregor at AWS.
Hi, everyone. Rob McGregor. I lead our solutions architecture team for Navy, Marine Corps, and combatant commands at Amazon Web Services.
And if there's any other Robs in the audience, feel free to come up and speak at any point. Apparently, that's the key to this presentation. We're going to talk about solution envisioning around these kind of edge capabilities, talk about a key capability that AWS is providing called SIGA, Cloud Edge Global Access, go through the overview, talk about some of the key capabilities there, and then get to question and answers with you guys pretty quickly. So one of the things that I want you guys to envision is, what if you had the ability to access 400 gigabyte Ethernet plane capacity across 600 points of presence across 48 countries? And then you had the ability to seamlessly access satellite communications, 5G communications, fiber, or even radio over IP. And that you could do this at IL5 plus. You could do this across multiple cloud configurations without any lock-in. And you can dynamically configure for topology and routing, and it's DDoS protected. Now imagine being able to do that, and you can stay connected to or from anywhere when you're in a DDIL type environment. And that, imagine that we could deploy this type of capability, these one-time use networks, in under 45 minutes. So let's give a scenario. Let's say we're engaged in a conflict, island hopping in the southeast AOR. We're subject to legacy communications being jammed. We're subject to our partners having bad communications or having their communications disabled. Their comms are challenged. We all know that comms are the lifeblood. How do we do resilient comms in a way where they're undeniable, that we have that capability to be able to have resiliency, multipath, dynamic in these types of environments? So Rob?
So the approach we're taking here is a reference architecture that we have called, we refer to as SEGA. So you see CEG, we pronounce it like the video game system SEGA, but as Rob mentioned, that's Cloud Edge Global Access is what it stands for. And what it really is it's infrastructure as code. So this is automation that we've provided, and we've been able to demonstrate and test to show that we can leverage our global backbone. And we'll get into details about what that global backbone is and why that's relevant to the architecture. But it uses a combination of various AWS services, so our backbone is a piece of it. We'll get into the details of the other capabilities within the AWS ecosystem that enable this. And then, as mentioned, it's fully automated. And as the solutions guidance, the way it works is we work with our systems integrators and our managed service providers. So people like SMX will work with the end customer in coordination with us to deliver that for our customers. So the scenario Rob laid out here is a common scenario. Hopefully it feels familiar to many of you, and some of the challenges resonate. So just think of that as kind of the thing we're working backwards from. At AWS, we always talk about being customer obsessed and taking actual customer needs and working backwards from those to deliver capabilities, and that's what we've done here. This is kind of an exemplar of what that scenario looks like. So in this case, we've got existing edge kits. So these are things that are common. We're talking about bringing existing equipment in many cases. We can also help work with our partners to help deliver relevant hardware for the solution. But when you see, SMX has in their meeting room today demoing this, that's equipment that is used for demonstration purposes. When you get to the actual use of this, you would use something that's relevant to your actual needs. But we have these two kits. So there's a couple of challenges with the situation. One is, if you look, there are challenges for Kit 1 and Kit 2 being able to actually communicate directly with each other. In this case, as we often see, there's a limited number of redundant network connectivity paths, often only a single one. And the customer, in this case, we're talking about getting to a mission workload. In this scenario, we're thinking of it at the secret level, the IL6 level, but this could also be at really any classification level. But they're trying to get to that workload that's hosted somewhere. In this case, it's a customer data center. That could also be within the AWS cloud. And they're doing that over potentially a long distance where their communications are not reliable, they're not necessarily resilient, and they're not necessarily high performing. The other issues here are that they're using fixed locations, so that if you see that ingress router on the customer data center side, that's often in a fixed location, and it creates limited flexibility. And with the US government-owned IP addresses that are used, that can be, from an adversary perspective, something that becomes visible and be very useful as a target. And so we try to address these problems. And the forward mass and maneuver, we'll talk a little bit about that, but if you're thinking at the edge, there's obviously many scenarios where you're not going to be fixed at the edge. So when you move, how do you continue to have that resilient communications infrastructure available to you? So taking that as this is the problem, this is the scenario, what are the requirements we derive from that to come up with a reference architecture that can be leveraged? So in our case, the requirements are enabling that mass maneuver in cyberspace. So this is really about maneuvering where you're actually hosting things, so they're less able to be identified and attacked. Rapidly deployable, so automation is key here. The ability to actually stand something up when needed to set up potentially tactical networks, or just to enable the network connectivity with that maneuvering in the physical space. And then this is like a derived requirement, but actually delivering that infrastructure as code for the solution and providing DDoS protection from a security perspective. For globally ephemeral ingress points, what we're talking about here is being able to come into the network backbone at any point based on where you physically are. And of course, it needs to be easy to use and it needs to be complete. We're not just talking about one capability, but providing that ecosystem of security and support as it relates to it and the analytics needed to enable that. So what's the solution? We'll show some diagrams, so it's less word and text heavy here in a minute, but I will verbalize a little bit about what we're trying to provide with the solution. So one is that automation of that global infrastructure. So we're using something we call CDK TF or CDK Terraform. So that's Cloud Development Kit. Basically, you can use your programming language of your choice to write infrastructure as code that gets converted into Terraform to actually provide the infrastructure. In this case, within AWS, we'll talk about how that actually creates flexibility to do this within other environments outside of AWS, including other cloud providers. Doing that within 45 minutes, as we talked about, is a requirement. Providing all that full automation. I'll kind of jump ahead so you can see more of the actual images of what this looks like. Now, I will caveat, this did have some animations, so I'll have to do some verbalization of what the animations were prior, but it doesn't have all the animations in place right now. So I'm going to talk about how this is delivered from an infrastructure as code, and I'm going to start in the middle and kind of work out, and there's a reason I'm doing that. It's kind of to think about how we actually lay this down from an infrastructure as code perspective. So if you look at the ingress points, when we lay down this infrastructure as code, we're laying down virtual router appliances within the AWS ecosystem, in this case within the commercial cloud environment. It doesn't matter what classification level your workload is or where your endpoints are. We can stand up this infrastructure in the commercial space within our global ecosystem, our global network backbone, and you can do this within your regions of choice globally. And then from there, we also stand up the egress points. So those egress points, in this case, are within our GovCloud environment. So that GovCloud environment is authorized for provisional, or has provisional authorization in impact level 4 and 5. So if this is to enable access to workloads within the AWS environment at that level, we're also targeting, as we talked about in the scenario, workloads hosted within data centers that are physically within customer premises. So coming back, after we lay that down, we deploy a virtual router within the hardware environment that you already have or that we help you provide with our partners. And then we use the automation also uses that router and does the configurations with the environment in the cloud to provide a full SD-WAN overlay across both the AWS network backbone as well as the other providers that are initially connected to the environment, which is really it's whatever you can get to from an internet perspective. But we talk about 5G, physical fiber, which you may lay down with circuits. Often that's not available to you. SATCOM, and then using a short path of the internet to get to our backbone over those network points of presence that Rob had previously mentioned. And we have another view of that to kind of visualize what we mean by getting on the backbone quickly and then writing that backbone. So I'll show that in a second. But before we do that, this is showing one of the paths to enable that communication between the two kits, because we're in these situations, we're not just trying to get to the workload, we're also often have multiple kits that need to communicate with each other as well. And so this is doing that where it doesn't even have to get to the ingress or to the egress routers. It's able to leverage the Amazon backbone, the ingress routers, and to get back out to the other kits for communication. So a little bit about our global backbone and why that's important and why it's necessary for leveraging. So when we think of this, stepping back a little bit, a lot of this is around automation of pace. So hopefully you all know what that is from a network perspective: primary, alternate, contingency, and emergency. So when you have pace defined for how you're getting communications within austere environments or for particular scenarios you need to meet from a mission perspective, you have different things you need to meet at those different levels. And our backbone provides a lot of resiliency. It provides high performance on a 400 gigabit Ethernet network. And you can see all these different points of presence and the various connectivities they have. We actually do a lot of laying down of our own fiber. And a lot of this is our own stuff that we own and additionally network that we lease. So we have this global footprint that we want to provide and allow the Department of Defense to leverage. So this is another view of what I showed already, but this is showing how this enables getting onto our backbone quickly, where that makes sense. Now, remember, we're talking about an SD-WAN overlay, so there's times where you can do this without our backbone, but oftentimes getting to our backbone quickly and then getting out to wherever you need to go is the most efficient path. And so in this case, if you kind of take the top level as a virtual view, and then coming down kind of the physical views of where we're enabling it, you can see that in this case, this is more from a right to left view is how to look at it. Your mission tactical environment is on the top right, and you're trying to get to the workload in the top left. And so to do so, you're writing the internet for the shortest path possible. That internet in this case might be that SATCOM or 5G or something like that. And then you're getting into publicly advertised IP ranges that we're providing via this capability we call Global Accelerator, which basically provides an anycast IP address advertisement across multiple of your choosing locations within the AWS ecosystem. And then you're coming down into our environment and then writing these virtual routers that are part of that SD-WAN overlay, and then getting out to the egress points before you can get to that environment. And that, in this case, you can get to the customer data center, but you can also get to an AWS workload, as shown on the bottom left there. So here's this massive maneuver scenario we talked about. So in this case, think of ships on the coast of Japan that are needing to access workloads that are in a customer environment. Those are fixed location. At one point, we have these yellow circles that are representing AWS regions where we have physical infrastructure. The little router icons are where you might have pre-deployed router infrastructure to enable this for those maneuvering. But the other thing that this enables is, even if we didn't have the pre-deployed router infrastructure, we can do that dynamically with infrastructure as code within that 45-second time frame that we talked about earlier. So when these ships come down, and unfortunately, we don't have the animations to show it right now, but when the ships come down, we can dynamically flip those. And we can see kind of zoomed out, what it looks like where we've got a bunch of routers deployed across the Amazon backbone, and we have this resilient architecture with network connectivity throughout this, obviously very important region. We also are talking about how to take advantage of other capabilities that we provide at the edge. So we have the capability called modular data center. That's not the focus point of this presentation, but modular data center basically provides an ICD 705 SCIF accredited physical capability that we can bring AWS infrastructure into, like Snowball edge devices or outposts, or third-party hardware into that can enable edge processing wherever you need it, local to your environment, but then also provide those virtual router deployments, both in those locations as well as within our actual physical cloud-hosted locations. This is zoomed out. It's important that we're not to point out that we're not just operating within that AOR. We often have to get back in to communicate to globally and to the US. And of course, we have, from a data sovereignty perspective, most of our workloads hosted within the CONUS United States, particularly from a cloud perspective, and particularly from an IL 4, 5, 6, and above cloud perspective. So this is an interesting concept. There's just a couple more concepts within this capability that I want to focus on. This one is around compartmentalized and time-bound deployment. So when we have this SD-WAN architecture, we have the ability to not just do like a single architecture that we deploy globally, but we have the ability to deploy multiple instantiations of this. And there's a number of reasons we might want to do this. Some of them are security relevant. Or many of them are security relevant. Some of them are actually from like a management perspective. It's easier to manage these smaller ones, especially if you have segregated reasons where these shouldn't communicate. But you might, even if it's not about the segregation, what you might want to do is have these pre-positioned deployments that you can flip between, and that provides this basically ability to hide the discoverability of this from a cyber adversary perspective. That you can do this as frequently as you choose to do. And then I mentioned this earlier, I alluded to it. When we chose CDK Terraform for the deployments, we did that intentionally. Obviously, a lot of customers are using Terraform to enable deployments in many locations, including other cloud providers. The other thing we did is from a connectivity perspective, if you look at how most people connect to cloud, if you look at like the BCAPs that are hosted by DISA, that's all using our direct connect capabilities, and those go through like Equinix facilities. We know the other cloud providers are doing that. We know you all are hosting workloads in these other cloud providers. There's capabilities with those partners to enable communications between those. So we can look at how do we bring those together for if you want to get to your workload in another cloud provider in addition to your workload in a data center hosted within your own data center, or within our cloud or within other cloud providers. You can also do it to actually communicate through that cloud provider in in situations where access to things gets completely shut down for various reasons. Finally, zooming out as kind of the overall architecture, there's two more things I want to call out on the slide that we haven't really talked about. One is, from a SATCOM perspective, as an Amazon employee, I kind of have to point out that we have Kuiper as an option that's coming, and Kuiper brings a lot of capabilities that are relevant to this. But one of them is the integration with our regions more directly. So from a network connectivity perspective, coming into workloads within our regions, there's a lot of synergies there. We have several Kuiper people here at this conference, and a lot of things that I can't talk about publicly in this forum, but if you want to talk under NDAs for partners that we have or government customers, we can have those conversations. The other piece I want to highlight is the secret region access. So a lot of this, we talk about kind of the overlays using type 1 encryption. You can actually use this even over our commercially publicized IP ranges to get to these routers. You can use that to bring back into our classified regions, and this is showing the IL6 in our secret region. So with that, I'll hand it back to Rob to sum it up.
Thanks, Rob. It really is amazing to see what you can do with resilient comms and how you can create an architecture that can leverage the best of what we've built internally, what the CSPs have provided to DoD, how multiple clouds can be leveraged in the situation. Your workloads are going to be everywhere. You have the choice and the flexibility to have this kind of an environment and be able to use these SD-WAN overlays to rapidly create these networks, create these points of presence, leverage the backbone and the billions of dollars of investments that AWS has made in their global infrastructure. Again, think about it, 600 points of presence, 48 different countries, 90 plus cities. And be able to do this in environments that are denied, disruptive, intermittent, limited, low bandwidth environments is really critical to the missions that we need to be able to support. On top of that, I really like the fact that you can do this at IL5, IL5 Plus. This really isn't limited by that. The ability to leverage the Terraform type capabilities so we could rapidly deploy these nodes. You saw some of the cloaking capabilities or the capabilities to mask and maneuver these networks to avoid our cyber adversaries from being able to disrupt these environments. The dynamic networking and routing capability, the ability to do the movement that we know we're going to have to do fast and be able to choose the paths that are going to be required is fundamentally key. And I'd like to invite you to the SMX meeting room to set up a demo around this, where you can actually see how we can rapidly enable these capabilities, point and click to choose the path that we want to. We can pull 3 or 4 ports out, and you can see the extended connectivity, even when we've lost SATCOM, or we've lost fiber, or we've lost any of our normal comm capabilities, that it's resilient. And resilient, multipath, flexible, adaptive are the kind of solutions that we need for the next level battles. And again, I want to thank you guys, but I don't want you to leave. I'm hoping that there are questions, or I'm hoping there are other Robs in the audience that just want to stand up and clap or something like that. But in general, we'd love to hear from you guys and answer your questions.